guys, welcome back to my channel. So in today's video we are going to solve lead code question number 2536, which is increment submatrix by 1. So in this problem, it is a medium level problem as you guys can see, and it will be involving efficiently updating submatrix in a 2D array. So the problem given is that we are given a positive integer n that we will be initially having an n into n, which n x n or n into n you can see. After that, uh, filled with 0, it will initially be filled with 0, and a list of you can say queries. So each query specifies a submatrix by its top, you can say, left corner and the bottom corner, right? Bottom right coordinates, and the task is to increment, like we have to increment every element in that subarray by 1. So after performing all query, we have to return our result as well, uh, the returning matrix. So let us understand this by the example. So here we are given n as 3 and the query as in two subarrays, which is 1 1 2 2 and 0 0 1 1. So we start with a 3 into 3 matrix. Okay, and after that, as you can see, 3 into 3 matrix, 3 3 3 3 matrix. So the first query increments the subarray 1 1, like 1 1 2 2 1. So see, the first query increments the subarray, which is 1 1 to 2 2. Okay, so it will be incrementing it, like we will be doing a addition of 1. And the second query increments the subarray 1 0 0 to 1 1. Okay, after that, both the final matrix become 1 1 0 1 2 1 and 0 1 1. So here to here we are going, right? So a straightforward approach would be to loop through like the every cell inside each query submatrix, right? And increment it, but this to become slow for large matrix or mini query. So to solve this efficiently, we will use two different array instead, right? Array technique. So I will be writing the code before we understand it. So once I'm done with the coding part, I will be and making you guys understand the code. Also, the second example is as easy as that, right? 0 0, then incremented by 1 1, so it becomes 1 1 and 1 1. Okay, so it's like that. Now let us write the code. We have written the class solution and public int 2D array with the range at query, which is in 10 int double, like 2D query, basically 2D array query. So first we will initialize n into n matrix with all zeros. So for that we'll write int 2D array and then matrix equals to, should not be matrix, it should be matrix equals to new int n, and in another bracket it should be n again. After this, we will be applying different array techniques for 2D range updates, which will mark the boundary of each of the query triangle. So for that, we are going to do a for loop, which is going to say int array query queries. Row L, it's not row L, row 1 equals to, which is query 0, and then int column 1 equals to query 1, int row 2 equals to query 2, and int column 2 equals to query. After this, we are going to like mark the top left corner with the +1. So we will write, it should be matrix row 1 in another array, which is the second dimensional array. We are going to write column 1 and we are going to write increment it. Okay, after that, So after that we are going to mark the position below the bottom right corner with -0. So for that we are going to write if row 2 plus 1 is less than n, then matrix row 2 plus 1, in another bracket it should be column 1, and here we will decrement it, right? So this is done. After that what we are going to do is we are going to mark the position to the right of the bottom right corner with again -1. So it will become if column 2 plus 1 is less than n, then matrix row 1 and column 2 plus 1 is going to be decremented, right? Till here we are done. After that we will mark the diagonal position, which is row 2 plus 1 comma column 2 plus 1 with +1 to compensate. Okay, so for that again we are going to write a if where row 2 plus 1 is less than n, and column 2 plus 1 is less than n, right? So we are going to open the curly braces and we are going to write that matrix row 2 plus 1 in the first array, and in the second array we are going to write column 2 plus 1, and it should be incremented. So after that we are going to build the final matrix using 2D prefix sum. So for that we are going to write a for int row equals to 0, row is less than n, row plus plus open braces for in bracket int column equals to 0, comma column is less than n, and column plus plus. Okay, so once it is done we are going to add the values from the cell to the left, right? So for if column is greater than 0, then we are going to open a curly braces where we are going to write that, sorry, matrix in bracket row, in another bracket we are going to write, it's basically array. Okay, it's not bracket, it's array here. So equals to matrix row and again column -1. So this is again done. After that we are going to subtract the diagonal cells which is included twice to avoid double counting. So for that we are again going to write a if row is greater than 0 and col is again greater than 0, col is basically the column, then the matrix row and the column will be will be minus equals to matrix row -1 and column -1. So this is done. After that we are going to return it. I guess there might some issue arise because I've not given proper alignment to the code, but it should have been. Let's see how it goes. We are returning the matrix. After that I have to give there 2. Let's see if it's running or not. There will be some error which I have to resolve. Okay, which is 22. Okay, just give me another time. Okay, so for the arrows, I just have to mention that I made a mistake in putting in the arrows. Here one arrow should, sorry, here one bracket should be there. I made mistake in putting in a bracket. So here should be one bracket and here should be one. And now I guess it will be running. So this was just the things that I have to do. If you want, I'll recorrect it again. Here the spelling is wrong of matrix. See, I've explained you the code. I'll again explain you the code. That's not an issue. So we'll write it once again so that okay, what we'll do is we'll again write the code once again so that even if like I am feeling a little confused while looking at it, so let's do this part again. Okay. So again, we'll say that we have given a class and a public int where 2D arrays are there. So after that, as we know that we are going to initialize the n into n matrix with all the zeros, right? So here we will be putting int first array, second array, and which is the matrix, right? Sorry, matrix equals to new int n n. Okay. After that, we are going to apply different array techniques for 2D range update, and we will mark the boundaries of each query of the rectangle, right? So after that, we are going to write a for where int array query is queries. After that, we are going to open the first curly braces inside, and there we are going to write that int row1 is equals to query, which is 0. Int column1 which is equals to query 1. Int row2 equals to query 2, and then int column2 equals to query 3. Till here we have written. Then what we are going to do is, after that we will mark the top left corner with +1. So for that we are going to write matrix row1 and column1. We will be incrementing it. Do not forget to put a semicolon. After this, we are going to mark the position below the bottom right corner with -1. So for that, again we are going to write a if in bracket row2 is row2 plus 1 is less than n. Then we are going to open a curly braces where matrix row2 plus 1, which is column 1, that is minus minus. After this, what we are going to do is, for the second thing, we are going to mark the position to the right of the bottom right corner with again -1 for column, right? So again we will be writing a if for column 2, again +1 is less than n, which is going to give us, sorry, matrix row 1, and here again column 2 plus 1, which is going to decrement. Okay, again. So we have wrote a code till here completely. I hope till here it is fine for all. As you can see, we have decremented here, and after doing twice decrementation, we are going to mark the diagonal position, which is row 2 plus 1, column 2 plus 1 with +1 to compensate. So it's like if row 2 plus 1 is again smaller or like lesser than n, and column 2 plus 1 again is less than n, then what we are going to get is a matrix where row 2 plus 1 and column 2 plus 1 will be getting incremented. So after this, we will be building the final matrix using 2D prefix sum, right? So here for that, for int row equals to 0 and row is less than n, row plus plus, we are going to again open up curly braces. Okay, so we are going to open up a curly braces where we are going to write a for loop for our column. In column is equals to 0 and where column is smaller than n, after that column plus plus. Okay, so till here we have written for loop for row and column, and now we are going to add values from the cell above. Okay, so again for adding we are going to write a if where matrix row column plus equals to matrix row minus 1, and here it should be column 1. Okay, so we are done till here. After that we are going to add the values from the cell to the left. So for that we are going to write again a if where column is greater than 0, going to open a curly braces where matrix row and column plus equals to matrix row and then it's column minus 1. With this we have ended this part. Now we'll subtract the diagonal cell includes 2 twice to avoid double counting. So for that we are going to write if row is greater than 0 and column is column is greater than 0, then we are going to write a matrix row column which is negative minus equals to matrix row minus 1, and here it is column minus 1. So here ends our matrix. After that we are just going to return the matrix and we are done with our code. So I hope this is not going to give us any more errors while checking the cases. So there is one error on line number 23rd. Let me check what is the error. Matrix row column plus equals to matrix row minus 1 and column. Okay, so till here it seems to be right. Can't find the symbol. What's the error here? Though I am checking, I don't feel there is any kind of error as such. Uh, Here it is row minus 1 and here it's column 1. So what kind of matrix row column? Okay, so for error here it shouldn't be column 1, it should be just columns, and that's what was the wrong part. And here we go. I hope it works. Yeah, both cases are working. That's a very wonderful thing. And let us understand the code. See, to solve this efficiently, we have used like a 2D array kind of, basically 2D array. So instead of updating every cell inside the matrix directly, we only mark the corners and like the borders. For each query, we increment top by +1, or we decrement it, right? And after that, what we are doing is uh, below the bottom boundaries, and the cell immediately to the right of the boundary also gets decreased, like decremented by 1. So you can say that finally we increment the cell. Here we are incrementing the cell. We are finally incrementing our cells, and what we are doing is outside the diagonal of the matrix to compensate for the over counting. So when all our queries proceed the way, we restructure the final matrix using a two dimensional prefix sums, where each cell becomes the sum of the values above it. So the value to the left minus the overlap here, the value to the left minus the overlap here, and the to the efficiently propagates the increment to the relevant one. So using this approach, we can handle large matrix thousands of queries in optimal time, especially O of n square plus number of queries, while using minimum extra space. So this method is elegant because it avoids repeating loop through like the submatrix, you can see, and leverage the power of different array combination with prefix sums to achieve the desired results. Thank you so much for watching. If you have any doubt, please do let me know in the comments.